Namaskar, Adab, Shat Sri Akal. Welcome to the iconic course of CSIRNet. Yes, this evening, what the things is going to happen, which topic is going to be dealt with. Certainly, we are going to discuss a very interesting concept of group theory. Yes, this evening is dedicated for Eulers Phi function. Yes, we are going to discuss a number theoretic function. Yes, Eulers Phi function. Actually, in group theory, we need the use of three very important functions like phi function, tau function, and sigma function, and all these are very useful certainly. So we are going to discuss what is Eulers Phi function in actual, है ना. Eulers Phi functions ये क्या होते हैं, ठीक है, इससे हम क्या फाइंड आउट करते हैं, ठीक है, किस तरीके से डिफाइन करते हैं, क्या Eulers Phi फंक्शन 1 1 होता है, क्या Eulers Phi फंक्शन ऑनटो होता है ना, किस तरीके से यह क्या क्या बताता है ग्रुप के बारे में, ये सारी बातें बेहद खूबसूरती के साथ आज हम डिस्कस करने वाले हैं. So you all are welcome over here, and on this channel we have also completed real analysis for CSIRNet, है ना. पूरा का पूरा जो कोर्स है रियल एनालिसिस का वह इस चैनल पे बहुत ही खूबसूरती के साथ हमने कंप्लीट किया है. यस, वी हैव कंप्लीटेड रियल एनालिसिस ब्यूटीफुली. मोर देन 90 videos of at least 1 hour, some videos of 2 hours is also there. Okay, a premium course has completed on this channel, one-to-one interaction you can say, because I used to discuss in a two-way communication. I would like to say first of all, when I will start Eulers Phi function, then I will arise a question, I will give the answer of the question, I will give you the intuition, problems, properties and everything in a very beautiful manner. So now let's go to start this session. First of all, we start with the definitions, but thereafter we used to come on the problems related to that as well. So सबसे पहला सवाल कि Eulers Phi फंक्शन क्या है, ठीक है. तो यह एक नंबर थ्योरेटिक फंक्शन है, नेचुरल से नेचुरल जाता है, ठीक है. Eulers Phi फंक्शन की डेफिनेशन में ही UN जो ग्रुप होता है, UN उस ग्रुप के ऑर्डर को डिफाइन करते हैं. उस ग्रुप के ऑर्डर के रूप में phi n को डिफाइन कई बार हम लोग करने की कोशिश करते हैं कि यह UN ग्रुप का जो है ऑर्डर देगा, ठीक है, यह Eulers Phi फंक्शन, ठीक है. तो अब वो किस तरीके से देता है, क्या नहीं है, लेट्स गो टू अंडरस्टैंड, है ना. सबसे पहली बात अगर हम बात करें Eulers Phi फंक्शन का, तो phi फ्रॉम नेचुरल्स टू नेचुरल्स, है ना. दिस इज योर Eulers Phi फंक्शन. एक एक बात यहाँ पे बहुत अच्छे से डिस्कस करने की जो कोशिश है वो हम लोग यहाँ पे करेंगे. Eulers Phi फंक्शन जो डिफाइन होता है सेट ऑफ नेचुरल्स टू सेट ऑफ नेचुरल्स, ठीक है. उसके बाद जो दूसरी बात है, गुड इवनिंग श्रवणिका, यू आर वेलकम. ओके, एंड इज डिफाइंड एज हाउ, phi फ्रॉम n टू n एंड इज डिफाइंड एज किस तरीके से डिफाइन होता है. Actually, phi of n is nothing but the order of what, x belongs to n, order of this UN group, you can say x belongs to n such that x is strictly less than n and all the elements, I mean to say the GCD of and x and n should be 1, ठीक है. Yes, तो what would you like to say about it? And Eulers Phi function is nothing but the order of this group which is defined as this one, and this is what, nothing but the UN group. Okay, many definitions will be discussed over here. I would like to say something that for example, if you know how to write U10, how to write U100 already, for example, if we will discuss about what U10, तो U10 में क्या सब आ जाएगा, व्हाट द थिंग्स आर गोइंग टू कम, x लेस देन n, जिसका इसके साथ U10 मतलब 10 के साथ जो को प्राइम बनाएगा, तो 1, उसके बाद 2 तो को प्राइम नहीं होगा 10 का, बट 3, 4 इज ऑल्सो नॉट को प्राइम विथ 10, है ना, GCD ऑफ 4 and 10 इज नॉट 1, फिर 5 इज ऑल्सो नॉट, 6 इज ऑल्सो नॉट, बट 7 and 9, so 4 elements are over here. So actually the order of this U10 is going to be given by phi of 10. Okay, and there are very interesting things to say that here the phi of 10 will be what, 4, because number of elements in U10 is 4. So this is the very first thing I would like to say. Phi of n, this Eulers Phi function is nothing but a function from naturals to natural, a number theoretic function which is going to give the order of the group UN. ओके, UN ग्रुप जो है इसका जो ऑर्डर है वो यहाँ पे देता है अगर हम Eulers Phi फंक्शन की बात करते हैं तो। अब जो दूसरी बात है कि इसको हम कैलकुलेट कैसे करते हैं, हाउ वी आर गोइंग टू कैलकुलेट Eulers Phi फंक्शन, सो सर्टेनली आई एम गोइंग टू डिस्कस ऑन दैट, बट यहाँ पे थोड़ा चार्जर काम नहीं कर रहा है। यस, नाउ इट्स फाइन। Yes, now everything is fine. So how we are going to calculate this, है ना, किस तरीके से हम इसको कैलकुलेट करेंगे, चलिए अब यहाँ पे देखते हैं। All right, देखिए, first of all we would like to discuss the formula from here only. Here is what, 10. Okay, so 10 can be written as the product of prime as how, 2 into 5, right? And thereafter you can calculate phi of 10 as, first of all write this n, here n is equals to what, 10, and thereafter 1 minus 1 by first prime into 1 minus 1 by second prime. This is how we are going to calculate. So it will become what, 10 into 1 by 2 into 4 by 5. Okay, so what would you like to say? It is nothing but 4. So don't worry, I am just going to give you the general formula for this. You should not worry at all. So what is the general formula? I would like to say, if you have to find phi of n, then first of all do the prime factorization of n, and you will not hesitate to say the prime factorization like this: p raised to the power a, q raised to the power b, r raised to the power c, and things like this is going to happen. Here this p, q and r are the primes and this is the powers. For example, if you have to find phi of 100, then you will just do what, here your n is equals to 100, then you will just write it as the product of power of primes. So it will become 2 raised to the power 2 into 5 raised to the power 2. So here p is equals to 2 and q is equals to 5 and a and b are 2. Okay, now see how we are going to calculate all these. So here you will say what, here your p, q, r, etc. these are primes undoubtedly, and this a, b, c and so on, this belongs to positive integer. Then how we are going to calculate, then what is the formula of phi n? Okay, so I hope you understood. आप समझ गए कि phi of n है तो n को सबसे पहले प्रोडक्ट ऑफ पावर ऑफ प्राइम के रूप में लिखते हैं। प्रोडक्ट ऑफ पावर ऑफ प्राइम के रूप में लिखने के बाद यहाँ पर जो फॉर्मूला है phi of n के लिए, Eulers Phi फंक्शन के लिए, उस फंक्शन के लिए जो कि UN ग्रुप के ऑर्डर को बताता है कि UN के अंदर कितने नंबर ऑफ एलिमेंट्स होंगे। तो अगर हम बात करें तो phi of n होता है n इंटू 1 माइनस 1 बाई पी। ठीक है, ये पावर मायने नहीं रखता, ये पावर कितना भी रहे। दिस प्राइम्स आर इंपॉर्टेंट फॉर Eulers Phi फंक्शन फॉर कॉम्पिटिशन, फॉर कैलकुलेशन पॉइंट ऑफ व्यू। सो phi of n will be what, n into 1 minus 1 by p into 1 minus 1 by q into 1 minus 1 by r and by doing so and so on। ठीक है, ये आपका सबसे पहला जनरल फॉर्मूला है। ठीक है, क्या है, आपको फाई एन कैलकुलेट करना है। एन को आपने प्रोडक्ट ऑफ पावर ऑफ प्राइम्स के रूप में लिखा, जो कि किसी भी नंबर को हम लिख सकते हैं। उसके बाद यहाँ पे पी क्यू आर ये सब जो है प्राइम्स को डिनोट करता है, ए बी सी ये सब पॉजिटिव इंटीजर्स है। तो यहाँ पे n इंटू 1-1/p इंटू 1-1/q इंटू 1-1/r एंड सो ऑन, ये आपको क्या दे देता है, फाई ऑफ n। यानी कि ये क्या दे देता है कि ये un में कितने नंबर ऑफ एलिमेंट्स होंगे। अब जैसे मान लीजिए हमें फाई ऑफ 100 कैलकुलेट करना है, तो फाई ऑफ 100 क्या हो जाएगा, तो n के जगह पे आप क्या लिखोगे, 100 इंटू 1-1/p, p क्या है यहाँ पे 2 इंटू 1-1/q, q क्या है 5। So in this way you can say 100 into 1/2 into 4/5, isn't it? Yes, 5 2s are 10, so it will become what, 40. So what do you mean by this? So phi of 100 is 40. By using this formula I am just going to yes, this formula, ठीक है। कई बार हमने बोल दिया n क्या है, p क्या है, q क्या है, r क्या है, सारी चीज़ें। अब देखिए यहाँ पे हमने एक एग्जाम्पल भी बहुत अच्छे से ले लिया। व्हाट वाज द एग्जाम्पल, सर्टेनली फाई ऑफ 100, हाउ टू कैलकुलेट फाई ऑफ 100, यू कैन सी दिस एज एन एग्जाम्पल। एंड एक्चुअली व्हाट इट सेज फाई ऑफ 100 इज व्हाट, द नंबर ऑफ एलिमेंट्स इन u100। ठीक है, तो u100 में कितने नंबर ऑफ एलिमेंट्स होंगे, तो 40। ठीक है, और u100 क्या होता है, तो वो सारा एलिमेंट्स का कलेक्शन जो 100 से छोटा है और 100 के साथ को प्राइम है। मतलब u100 का जो ऑर्डर है वो यहाँ पे फाई ऑफ 100 बताता है। और भी बहुत सारी बातें हैं, जैसे कि अब बहुत सारे सवाल यहाँ पे निश्चित तौर पे आते हैं कि ये जो आपका एलर्स फाई फंक्शन है, क्या यह 1-1 फंक्शन होगा, क्या यह ऑन्टो फंक्शन होगा, क्या यह इवन फंक्शन होगा, क्या यह ऑड फंक्शन होगा, कब क्या होगा, कब क्या नहीं होगा। Okay, all these things are going to be discussed. I would also like to ask, say one more thing, that if you have this thing, phi of mn, okay, for example, let's see, if you have phi of m into n, in that case you can write it as phi of m into phi of n. Okay, this is the second formula. Third formula is what? Yes, you will not hesitate to say, if you have phi of p raised to the power n, where this p is prime, then in this case it is going to be p to the power n minus p to the power n minus 1. And certainly we will use this formula also to calculate phi of 100. Okay, so for example, if you have to calculate phi of 100 by using this formula, then certainly what can you say? You can say this is what, phi of 2 raised to the power 2 into phi of 5 raised to the power 2, and here you can say what, p raised to the power n minus p raised to the power n minus 1. So we will use this formula over here. So it will become what, 2 raised to the power 2 minus 2 raised to the power 1, phi of 2a square, and into phi of 5a square will be what, 5 raised to the power 2 minus 5 raised to the power 1. So certainly this is going to become 4 minus 2, which is 2, into 25 minus 5, which is 20, so it will become 40. So number of elements in phi of 100, I mean to say number of elements in u100, which is going to be given by 500, is 40 also. So this kind of calculation is also going to happen. You can say that this is a general formula. Phi of n is equals to n into 1-1/p into 1-1/q into 1-1/r. This is a general formula, but yes, these are also some special kind of properties and formula you can see over here. Phi of mn is equals to phi of m into phi of n, and phi of p raised to the power n is p raised to the power n minus p raised to the power n minus 1. Yes, so certainly we can see all these things. So now here is a very simple question of CSIR net. I am just going to ask, and thereafter we will discuss some properties of Eulers Phi function. Okay, so yes, the question was what, it was asked in CSIR. I am just going to write, set S was given, A belongs to naturals such that A lies between 1 to 1000 and the GCD of A and 1000 was 1. Okay, then the cardinality of S is what? The cardinality of S is what? Option A 40, option B 100, option C 300, option D 400. You just need to say about it. Okay, so certainly Eulers Phi function will help you over here, but how? You just need to say about it. If anybody is there, then certainly they are welcome to speak. That if the given S is equals to what? A belongs to N, A lies between 1 to 1000, GCD of A and 1000 is 1. I mean to say you have to take the collection of co-primes of with 1000. So certainly they are just going to say about U1000, isn't it? This is how U1000 is defined. So actually they are just asking the order of U1000. Okay, so if anybody is there, then they are certainly welcome to speak. Otherwise, I will give you the answer in a proper way, in a proper manner. Come on. Okay, if anybody is there, then please let me know. So first of all, I would like to say actually you have to find what? Number of elements in U1000, right? Number of elements in U1000. So this will be given as 5 of 1000. And what is the prime factorization of 1000? Certainly we already know 2 raised to the power 2 into 5 raised to the power 2 is what? 100. But we need 1000, so we need to multiply with 10, so we will increase 1, 2 and 5 more. So certainly 2 raised to the power 3 into 5 raised to the power 3 is what? The prime factorization of 1000. So by using the properties of Eulers Phi function, what would you like to say about? It will become 5 of 2 raised to the power 3 into 5 of 5 raised to the power 3. So this is what? 5 of 2 raised to the power 3 will be 2 raised to the power 3 minus 2 raised to the power what? 2, isn't it? Because p raised to the power n is going to become p raised to the power n minus p raised to the power n minus 1. So this is the thing. And here is what? 5 of 5 cube. So it will become 5 ka cube minus 5 ka square. So this is going to be what? 8 minus 4. So certainly 4. And 125 minus 25. So this is 4, isn't it? Yes. This is 4 and into 100. So this is going to be 400. So number of elements in U1000 will be what? 400. 5 of 1000 is what? 400. So this is what I wanted to say. Okay. Yes. So now here is a very beautiful question. Is Eulers Phi function 1 1? Then what do you think? What would you like to say about? Is Eulers Phi function 1 1? Is Eulers Phi function 1 1? क्या Eulers Phi function 1 1 होगा? ठीक है, क्या Eulers Phi function 1 1 होगा? ठीक है, तो I would like to say कि Eulers Phi function is going to be defined from set of naturals to set of naturals. Okay, I mean to say, yes, this is the codomain. So when we used to say this function is 1 1, when each and every elements of this natural should have unique preimage. Should have what? Unique preimage. Unique preimage. For example, if here is 1 2 3 5 and so on 10, and by doing so 8 is also there. Okay, so unique pre-image should be there in this domain wala naturals. But what the thing is going to happen? When you are going to calculate phi of 5, then this is what? 5 raised to the power 1 minus 5 raised to the power what? 0. So this is what? 5 minus 1 is equals to 4. And what about phi of 10? Phi of 10 is also what? What would you like to say? Phi of 10 क्या होगा? तो ये भी आप देख सकते हो, ये क्या हो जाएगा? Phi of 2 into phi of 5. So phi of 2 is what? 2 raised to the power 1 minus 2 raised to the power 0 into 5 raised to the power 1 minus 5 raised to the power 0. So this is a 2 minus 1, so certainly 1 into 5 minus 1 is certainly 4. So this is 4. So what are the things you are going to observe? You can see the pi, the image of 5 is what? 4, and the image of 10 is what? 4, isn't it? So 4 has more than one pre-image, and 4, which is the element of the codomain, has more than one pre-image. Therefore what would you like to say? It is not 1 1. इसीलिए यह 1 1 नहीं होगा, क्योंकि यहाँ पे ये जो नेचुरल है ना 4, इसका एक से अधिक प्री इमेज है. ठीक है, यस. फाई ऑफ 8 भी क्या होगा ये बताइए? फाई ऑफ 8 ये भी 4 होगा क्या? तो ये क्या है? 2 का क्यूब है, तो ये हो जाएगा 2 का क्यूब माइनस 2 का स्क्वायर. सो 8 माइनस 4 इज इक्वल्स टू 4. फाई ऑफ 8 भी 4 हो रहा है, लीजिए, है ना. हालांकि 2 प्री इमेज भी दिखा देंगे तो ये कंफर्म हो जाएगा कि ये 1 1 नहीं है, बिकॉज इफ दिस एलिमेंट्स हैज मोर देन वन प्री इमेज, इट मीन्स इट इज नॉट गोइंग टू बी 1 1, है ना. सो दैट्स वाई दिस इज नॉट अ 1 1 function. Eulers Phi function is not a 1 1 function. And now I am going to discuss a very interesting thing, that if n is greater than 2, then Eulers Phi function is always even. Yes, very interesting theorem you can say. What the thing is there? A very nice result, that if n is greater than 2, yes, I am talking about strictly greater than 2. If n is strictly greater than 2, then Eulers Phi function, Eulers Phi function is always even. Okay, if n is strictly greater than 2, then Eulers Phi function is always even. How can you prove it? Yes, its proof is very nice. You can just take n strictly greater than 2, and what is the case 1? Case 1 is what? If n is equals to 2 to the power k, and k is greater than or equal to 2, then what do you think? Phi of n is equals to phi of 2 raised to the power k for sure. And this 2 raised to the power k can be 2 raised to the power k minus 2 raised to the power k minus 1. Is this fine? From the formula, है ना. So phi of n is equals to phi of 2 raised to the power k, which is equals to 2 raised to the power k minus 2 raised to the power k minus 1. So we can just take 2 raised to the power k minus 1 as common, and then we are going to get 2 minus 1, which is certainly 2 raised to the power k minus 1. Okay, so what do you think? You can see phi of n in terms of 2 raised to the power something. So since k is greater than or equal to 2, then 2 raised to the power k minus 1 is always even number. Always even number. Okay, so one thing is clear, that when your n is strictly greater than 2, then what the thing is going to happen? Okay, so certainly we are going to get an even number, and we have seen it beautifully. Yes, certainly the proof makes the things more clear. That's why I am going to give all these. So hence we can say what? Phi of n is equals to phi of 2 raised to the power k is an even number for sure. But now one more question arises. What is the question? If n is not equals to 2 raised to the power k, then what would you like to say? मतलब अगर n जो है, पहला जो केस लिया जब n 2 का पावर k है, तब तो देख लिया कि इवन आता है, लेकिन थ्योरम क्या है कि अगर n स्ट्रिक्टली ग्रेटर देन 2 है तब भी आइलर्स फाई फंक्शन हमेशा इवन नंबर देता है. ठीक है. So now we will take another case and then we will try to prove that. Okay. So now let's take another case. What is that? So in this case we are going to take the second case, which is the case number 2. If n is not equals to 2 raised to the power k. n अगर 2 के पावर के रूप में नहीं लिखा जा रहा है, बट n अगर स्ट्रिक्टली ग्रेटर देन 2 है, फिर भी फाई ऑफ n कैसे एक इवन नंबर देता है. वी आर जस्ट गोइंग टू प्रूव इट. ठीक है. सो n इज नॉट इक्वल्स टू 2 टू द पावर k, देन इन दैट केस वी विल से व्हाट, देन n इज divisible by some odd prime, है ना. डिविजिबल बाय क्या है, सम ऑड प्राइम से p. ठीक है. तो हम मान लेते हैं कि n जो है डिविजिबल है किसी ऑड प्राइम से, और उस ऑड प्राइम को हम एक सिंबल के रूप में p के रूप में यहां पे लिख रहे हैं. ठीक है. देन इन दैट केस व्हाट द थिंग इज गोइंग टू हैपन, n कैन बी रिटन एज p रेज टू द पावर r इनटू m बिकॉज इट इज डिविजिबल बाय सम ऑड प्राइम. तो निश्चित तौर पे इस तरीके से लिख सकते हैं. And one more thing, the greatest common divisor of p raised to the power r and m will be what? Certainly 1. And this is true for r is equals to 1, 2, 3 and so on. So here in this case, what the beautiful thing is going to happen? Yes, you cannot hesitate to say that if phi of n is over here, then it can be written as phi of p raised to the power r into m. And by properties of Eulers Phi function, we can just write it as phi of p raised to the power r into phi of m by the properties of Eulers Phi function. And phi of p raised to the power r is what? P raised to the power r minus p raised to the power r minus 1 into phi of m. Okay. So this is what? This is phi of n. So from here we can say what? We can just take p raised to the power r minus 1 as common into p minus 1 into phi of m. Yes. So this is the thing. This is how we are going to calculate phi of n. Since p is an odd number, therefore p minus 1 will be what? What would you like to say? Since p is an odd number, p जो है एक ऑड नंबर है, तो p माइनस 1 क्या होगा? इवन होगा. और इवन मल्टीपल ऑफ एनीथिंग क्या हो जाएगा? इवन. तो हो गया ना प्रूफ. बस फॉर्मेलिटीज बची है, उसको लिख रहा हूं. सिंस p इज एन ऑड नंबर, देयरफॉर p माइनस 1 इज एन इवन नंबर. ओके. So p minus 1 is an even number, therefore finally you can say this is certainly an even number. So we have proved a very beautiful thing that if your n is strictly greater than 2, then in that case phi of n is always a even number. So it has been proved beautifully. No matter the n can be written as the power of 2 or cannot be written as the power of 2, but phi of n is always an even number if your n is strictly greater than 2. So you must remember this. Okay, so now I am going to ask one more question and you have to be very careful to say the things. And this is also very important. If anybody is there, then certainly I just want to see some response. Otherwise, I am very happy to discuss all these things. Okay, is Eulers Phi function onto? What would you like to say? Is Eulers Phi function onto? क्या Eulers Phi function onto है? Yes or no? What do you mean by onto function? Actually, this number theoretic function phi from naturals to naturals, okay, and it is defined such that phi of n is going to give you the order of un. Already in the beginning of this class we have already discussed it, but now the question is Eulers Phi function onto? What does it means? What they want to ask? They just want to ask, is the range is equals to naturals? Because you know, and this time Srabanika is saying something, she is saying no, this is not going to happen. If anybody is also there, then they are certainly welcome to speak, otherwise I will go for the discussion. Okay, so the answer is no. And it is very, very clear from the previous result. It is very, very clear from the previous result. Why? Because you had already seen that if your naturals is strictly greater than 2, okay, then in that case what the thing is going to happen? For example, if we are going to take phi of n is equals to 5, and if we are going to take n greater than or equal to 5, then what the thing is going to happen? Phi of n is equals to 5 where n greater than or equal to 5 is not possible. Not possible. Why? Because we had already seen a theorem ki if your n is strictly greater than 2, then as the output of phi of n you should have an even number, but 5 is odd. So 5 does not have pre-image. Okay. So that's why, what would you like to say? This phi from naturals to natural is not an onto function. Not an onto function. So that's why this is not an onto function. Okay. So yes, the properties of Eulers Phi function has already discussed, and I would like to say there is a lot of things that should be discussed, but in the next class only, because it is about to be 40 minutes. I have to do some more interesting things. Okay, but for now I would like to say we'll discuss the problems on Eulers Phi function tomorrow. Problems on Eulers Phi function. Eulers Phi function, but on tomorrow at 8 PM. कल 8 बजे शाम में आइलर्स फाई फंक्शन पे क्या क्या प्रॉब्लम्स हो सकते हैं, आज तो मैंने उसके प्रॉपर्टीज और उस पर कुछ बेसिक एग्जांपल्स करवाए, और नेक्स्ट क्लास में आइलर्स फाई फंक्शन पे क्या क्या प्रॉब्लम्स हो सकते हैं वो हम निश्चित तौर पे डिस्कस करेंगे. जो हमारा टेलीग्राम चैनल है उस चैनल पे हम कुछ क्वेश्चंस का सेट भेजेंगे. यू शुड ट्राई इफ यू आर इंटरेस्टेड टू क्रैक CSIR नेट और IIT JAM. Okay. So you must try those questions, and certainly we will come up with some more interesting number theoretic functions like tangent function, like sigma function in the next class. Till then, take care. Bye bye. We'll see you in the next class. All the best for everything which is going on in your life. And I would like to say thank you very much, Shrabanika, Neetu, and everyone who is watching this lecture right now or who will watch it recorded. Okay, so we'll see you in the next class. Till then, take care. Bye bye. Good night. Jai Hind, Jai Bharat, Vande Mataram.